In this lecture, I will focus on describing general concepts that you should know before we discuss descriptive statistics in greater detail. I will focus on reviewing the key differences between categorical and continuous variables and the different scales of measurement. It is important to be able to differentiate among these constructs because the scale of measurement of the variable you are examining will influence the types of descriptive and inferential statistics that you are able to conduct. Let's begin with a quick review of categorical and continuous variables. I would like you to pause the video here and take a moment to think about how you would classify each of the following variables. At this point, you may have made the following classifications. However, the classifications could really vary based on how the data were collected. Some researchers discuss gender in the context of range of masculinity and femininity. This does not break down into discrete categories of genders, but rather varies on a continuous scale. We can also discuss age based on age groups, 0 to 10, 11 to 18, 19 to 25, 26 to 35, etc., as opposed to the number of years the person has been alive. That would make the data categorical, as opposed to being continuous. Shoe size is another ambiguous variable in this list. We could discuss the actual length of the shoe, which would be different from the categories of shoe sizes available. Given these nuances, what rules of thumb can we use to determine whether or not data is categorical or continuous? A key guideline that can help us differentiate between these two is that categorical variables have values that consist of separate, indivisible categories, whereas continuous do not. This essentially means that you're able to interpret fractions between whole numbers for a continuous variable, but not for a categorical variable. It is important to note that whether a categorical variable has two categories or 1,000, it is still categorical if this property of the data exists. Categorical and continuous variables form the broad classifications of variables that we'll discuss in this class. We can fine-tune our descriptions of these data even further by discussing scales of measurement. There are four main types of scales of measurement. These build on each other such that as we go along the spectrum, the scales become more precise. At the lowest end of the continuum is a nominal scale. With nominal scales, as the name suggests, numbers are assigned mainly to name or identify the variable. The value of the number is not meaningful, nor is the distance between the numbers. A common example of this is gender. If we assign a 1 for male and a 2 for female in a data set, we cannot interpret that women are better because the value assigned to them is higher. We also cannot interpret fractions between the categories of male and female. Ordinal scales are more precise than nominal scales. With such scales, you're able to interpret the value of the number, but not the distances between the numbers. A classic example of this can be found in the context of sports. Athletes that are placed first and second in a race during the Olympics have only fractions of seconds in the difference between their times, as opposed to athletes that are placed first and second in high school races, who has seconds and maybe minutes in the difference between their times. Ordinal scales treat these two cases the same because they don't take into account the distances between the numbers. These scales only take into account the position or rank of the number. Both nominal and ordinal scales are considered to be categorical variables because in both scales the distance between the values is not interpretable. On the other end of the spectrum, interval and ratio scales are more precise, with ratio scales being the most precise of the two. Both scales are considered to be continuous because it is possible to interpret the distances between the values. The difference between an interval and a ratio scale is that a ratio scale has a true 0 point, whereas an interval scale doesn't. An example of this can be seen with the measurement of temperature, in which a Fahrenheit or Celsius scale are both considered interval scales because a 0 on that scale does not reflect the absence of heat. However, on a Kelvin scale, there's a true 0 point, in which 0 indicates no heat. Teasing apart the differences between interval and ratio scales can be difficult. Throughout the rest of the course, we will be collapsing these two scales of measurement into one. However, it is important to know that there is an underlying difference between these two. Let's recap with a quick self-quiz. Pause the video here and take a moment to think about how you would classify each of the following variables. Here is how these variables would be classified. Country of birth would be a nominal variable because the values used to number the countries would not be interpretable. Their sole purpose would be for labeling purposes. Faculty position would be an ordinal variable because the values used to indicate the positions only represent rank and do not take into account the length of time the faculty member has been with the organization. IQ scores would be an interval variable because there is no true 0 point in IQ. If the person is alive, they have an IQ score. Finally, the ratio variables represented in this list are weight, height, and temperature. In these variables, the scale of measurement begins at a true 0 point. For temperature, this is most true when evaluating heat using a Kelvin scale. You should now have a better understanding of categorical and continuous variables and know how to differentiate among the 4 scales of measurement. Like I mentioned, we will be building on these concepts throughout the course, so be sure to ask questions if any of these concepts are still unfamiliar to you.